Good day, folks. Here's another question on the rate of reaction. Don't forget to subscribe. Don't watch all my videos if you're new here without subscribing. Please do the right thing. Watch my videos till the end, like all my videos. The reaction between sodium carbonate and the sulfuric acid was used to investigate one of the factors affecting the rate of reaction. The balance equation given below is a sodium carbonate, sulfuric acid, sodium sulfate, carbon dioxide, hydrogen oxide. Two experiments are conducted. This is experiment 1. The content inside here is 150 grams, but the sodium carbonate, it's in lumps, if you can see there, and then it's covered or it's dissolved in the highest hydrogen sulfate, which is the sulfuric acid, and that's the mass, which is the initial mass, and this is the mass balance, which is the scale. Experiment 2, same sodium carbonate, but now this one is in the state of division here, which is the surface area. It's the powder and the same content, right? And it's covered with the sulfuric acid there. So the difference between the two experiments is the surface area. So this one has a powder and this one is a lumps, which means this one has a greater surface area. That means the rate of reaction of experiment 2 will be greater than the experiment 1, right? It says both experiment the same amount of sodium carbonate is added to an excess sulfuric acid, and then in solution in a conical flask placed on a mass balance. The mass of the flask together with its content is recorded every 15 seconds. Now the question 4.1, it says define the term rate of reaction. Guys, the rate of reaction, I'm not going to write that, is a change in concentration of product or concentration per unit time. Exam guideline, guys, when it comes to that, strictly exam guideline. Now 4.2, it says for this investigation described above, write down the independent variable. Right, guys, the independent variable, guys, it's always the factor that has been changed in both experiment, which is the state of division. The difference here, it's what is different. So what is different here? It's a state of division. So this one is a powder, this one is a lumps. So the independent variable here, is the surface area, right? And then one control variable. The control variable here, we can say it's a temperature, or we can say another one, it's a concentration of what? Of sulfuric acid, or you can say the absence of catalyst. That's the control variable. Remember, control variable, it's what has been not changed in both experiment, that is the same, that remains constant. Now it says the results obtained in experiment 1 shown below. Here the results at zero time, it was the initial mass, and then the mass decreases. Remember, the mass decreases because of the carbon dioxide that is emitted there. So as the carbon dioxide is emitted there, the content, the mass decreases. It decreases up until at 75 seconds the mass remains. At 90, in fact, at 90, the mass remains what? Constant. Do you see? At 90, that's when the mass remains constant. Now it says, now write down the name and the formula of the substances responsible for the decrease in mass. As I just mentioned now, it's the carbon dioxide. I'm going to write the formula. It's the carbon dioxide that is responsible for that decrease. As the carbon dioxide is emitted there, and this mass decreases. Now it says, how long does it take for the reaction in experiment 1 to be completed? It took, when the mass is the same there and it does not change, That means when it started to be the same, that means the reaction has reached completion where at 90 seconds. So the answer there, it's 90 seconds. Now it says how will the rate of reaction in experiment 2 compare to experiment 1? So the rate of experiment 2 will be greater than. The answer there is greater than. Now it says briefly explain, right? So referring to collision theory. So how you explain that is 4.5. What is the difference there between the two? So the answer there is greater than first, and then explaining that. So there's a difference there is a surface area. So you'll say experiment 2 has a greater surface area than experiment 1. That's 1 point. How many marks there? And then it's 2 marks. And then at the last point there you will say more collision. No, you say more effective collision per unit time there. Or you can say here in this point, that is the same point, there's more particles with correct orientation or more particles exposed there. That's 1 point. Right, let's move to the 4.6. It says the sketch graph below, not drawn to scale, represent the results obtained for experiment 1. This is experiment 1, right? The experiment 1, the mass started there. As the carbon dioxide is emitted there, the mass decreases up until the 19th seconds there. That's when the reaction stopped. So this is the initial and this is the final mass. This is the initial mass and this is the final mass, right? It says from this graph, guys, we can obtain the mass of carbon dioxide used. The mass of carbon dioxide used there, the mass carbon dioxide released, therefore it can give us the mass of the sodium carbonate that is used there. So what we can do here, it says use the information on the graph to determine the mass of sodium carbonate reacted. So it's 5 marks. So this difference here from the initial minus what is used there, what is left, this is the amount that is left, this is the amount that was there initially. So it can give us the amount of carbon dioxide produced. So it's 145.60. So what we can do, guys, I can just do it here, the calculation. Let me use a different color pen. So what I can do here, this is 4.6.1. So I can calculate the difference in mass. This is the mass of carbon dioxide, which is, I will say, the initial mass minus 145.60, which is, when I punch that in the calculator, it gives me 4.4 gram. That's the mass of the carbon dioxide released. That's the mass decrease of the 150 content. So from getting that mass, I can change this mass of carbon dioxide into number of moles. So changing that into number of moles, the mass of the carbon dioxide is 44, and then when you punch that in the calculator, it will be 0.1 mole, right? That 0.1 mole is the number of moles of carbon dioxide, and then we'll do the ratio, the mole ratio from there we have the carbon dioxide we want, the sodium carbonate. The ratio is 1:1 there. So we'll say the number of moles of sodium carbonate is equivalent to the number of moles of carbon dioxide, right, which is at 0.1 mole, right? So we have the number of moles of sodium carbonate. We can change now into mass, right? We can say 0.1, and then we divide by, we want the mass. The molar mass of the sodium carbonate is 106, and then we cross multiply. This is the mass of what? Sodium carbonate, which is going to be 10.6 grams. So we answered, this is the mass of sodium carbonate reacted. This is the mass reacted there, right? So now the question, now it says, okay, this is the previous answer. Now the last question here, it says redraw the sketch in your answer book on the same set of axes and to sketch the curve obtained for experiment 2. Now experiment 2, guys, as we said, that it occurs at a higher rate. So it occurs at a higher rate, and we are told to sketch on the same set of axes. So we have to redraw this, but I'm not going to redraw it. And then you sketch experiment 2. Experiment 2 is going to be like that. And it produces the same amount of carbon dioxide, the same amount. So that's why the time it ends at the amount, this is the amount that it ends there. So this is what? Experiment 2, and this is experiment 1. We're told to label experiment 1, experiment 2, right? I hope that makes sense, guys. Cheers, bye.